This lesson is for trigonometry on the reference angle or the reference triangle. I have a couple of them drawn here for you, and I'll illustrate them more in depth. But the angle here is from here over to here. There's your terminal side. The reference angle is with respect to the nearest x-axis, in this case 180 degrees or pi. In this one, this is a third quadrant angle. It goes all the way around to here. Now that's highlighted in yellow here because this is the reference angle with reference to the nearest x-axis, not the y-axis, the x-axis. And of course that's 180 degrees. If you're in radians, you use the pi. And then here's an example of the reference angle or the reference triangle. Even though this is a very large angle around to here, the actual reference triangle is right here with respect to the 360 degree axis. So we need to know this because with sine inverse, we're going to have the sine inverse of the trig ratio equals the angle. We're going to be looking these up on the calculator and having to correct them somewhat from the calculator. Often this will give you the reference angle if it's in the right quadrant. And then once you get the reference angle, you turn it into the reference triangle, and you have sides A, B, and C. Of course, the Pythagorean theorem, the C is the hypotenuse. It's always positive. The hypotenuse is, even though the sides of the triangle may be negative. So for instance, on this first one, this would be a negative x value, a positive y value, and a positive hypotenuse. In the second one, it would be a negative x value, a negative y value, and a positive hypotenuse. And in the third one, it would be a positive x value, negative y value, and a positive hypotenuse. Hypotenuse is always positive. We'll go into this more. Calculators can't give third quadrant angles to us. Example of that would be 120 degrees, which is a second degree angle. The nearest x-axis is 180, so when you subtract it, the reference angle or triangle would be 60 degrees right here, even though we're looking at this one. And then 220 is a third quadrant angle. Well, the nearest x-axis is 180 degrees, so you subtract 310 from 180 and you get 30 right here. That would be the reference angle. And then go into fourth quadrant, you have 315 degrees. In fourth quadrant, the nearest x-axis is 360, so you subtract 315 from 360 and your reference triangle or your reference angle would be 45 degrees. Take the reference angle and put it in radians. Here we have 9 pi over 10. Now 9/10 is less than 1, so it's less than 1 pi, so that puts it here in the second quadrant. Remember, 1 pi is only 180 degrees. 2 pi is 360. So this is a second quadrant angle. The nearest x-axis is pi, so I should take pi and subtract the 9/10 pi from it, and I get 1/10 pi radians, and that would be the reference angle right here in this reference triangle. The next one is 2.7. Notice it doesn't have a degree mark on it, but it does have theta, so that tells me we are in radians. So that would make this a 2.7 negative 2.7 radians, which would be backwards. 2 radians, negative 2 radians would be about right here. Negative 2.7 would be about right there. This is third quadrant. The nearest x-axis again is pi, so I subtract that from pi, and 2.7 minus pi, this is the wrong number here, would give you another value there. Okay, sorry for the interruption there. That was a subtracted pi minus 2.7 is 0.4416 radians. That would be this angle right in here. The next one is radians. 15 fourths pi, or 15 pi over 4. A little more difficult here. We'd have to figure out what quadrant that's in. And to do that, you would divide 4 into 15, and you would get 3 3/4 pi. You would divide that into 2 pi, which is one full circle, and the remaining part of the circle would be 1 3/4. So 1 pi would be over to here, and 3/4 more would be over to the fourth quadrant there. So the nearest x-axis is 2 pi after eliminating one full rotation. Again, this is related to the coterminal concept or periodic concept, where 2 pi is taken out first so you can see exactly where it is. So when we take 2 pi, which is the nearest x-axis, minus 1 3/4 pi, you get 4 pi radians. So this is an example of reference angle that becomes very important as we look up the sine, cosine, tangent of things, and we'll keep referring to this later.